Hello everyone, welcome to my channel Indian School of Physics. This is Nitin here, and today again I'm here with a very important concept application of JEE Physics. And as you can see, the name of this video is Radius of Curvature of Cycle on a Turning Path. And this is the diagram of the cycle which we are going to use in this. And yes, apart from the radius of curvature, we are going to discuss a lot of things like friction and coefficient of friction for no slipping conditions. Okay, so let's go and discuss this problem. So here is the statement of this problem, and it is given a cycle of length L0 and mass M0 is turning with a constant speed of V0. For simple model of cycle, take the assumption that center of mass is at the midpoint of the cycle and its center of mass is having a speed of V0, and the cycle remains in the vertical plane and does not skid on the ground. It is also given that the front wheel is rotated by an angle of theta in order to take turn. Find number 1 is radius of curvature of center of mass of the bike or cycle. Second is net friction force acting on the cycle. Third part is the radius of curvature of rear wheel and front wheel. And fourth one is limiting value of coefficient of friction to prevent slipping. So these are the ideas. Mainly here we are going to discuss about the translation part of this motion, and I'll be coming up with another video on the cycle where I'll be discussing the rotational dynamic concept on the same topic. Alright, so let's start our solution here. So as you can see in the diagram here, I'm assuming a simple model that this is the top view, by the way. This is the top view. So here, this is the front view, which is normally used for taking turn. And this is the orientation of the cycle along this length. Rear wheel will be in the same alignment as the body of the cycle. It is the front wheel which will decide the turning part. So from the body of this cycle, this turning front wheel is making angle of theta. This is given to us in the problem. Length of the cycle is also given to us. So basically here front wheel is rotating in a different circle, or let's say its radius is R2, and this rear wheel is rotating in a different circle of radius, and let's call this radius as R1. Similarly, the center of mass is the midpoint here. Its velocity is V0, which is given to us in the problem again, and its radius of curvature, or it is moving in a radius of RCM. Alright, so combined normal reaction on the two wheels, that is N1 and N2, this combined value, it is equal to mg. Gravity is into the plane here, into the plane of the paper. And also there are going to be two different friction 1 and friction 2 on these wheels, but I am interested in calculating the overall friction force, because in order to find FR1 and FR2 values separately, we will need more information. However, in the question here he is asking the overall friction force, and we can find out the direction as well. Alright, so let's start for this part. So as you can see here, I'm assuming R1, R2, RCM be the radius of curvatures of rear wheel, front wheel and center of mass respectively. Then you can see this geometry here. This length is L, and if this angle is theta, this is going to be 90 minus theta. Alright, so this angle is going to be 90 minus theta. Sorry, this angle is 90 here. This theta, this is 90, and this angle is going to be 90 minus theta. And if this angle is 90 minus theta, we can say here angle is going to be theta. So in this right angle triangle, we can write tan theta is equal to this length L1, L divided by R1. So directly we are going to get radius of curvature of rear wheel, that is L by tan theta in this situation. Similarly, I can write sine theta in this triangle. I can write sine theta, and that is going to be this sine theta is going to be L by R2. This sine theta is going to be L by R2 here. So we can see here, we can directly get the value of radius of curvature of front wheel as well, that is L by sine theta. Now for RCM. Suppose we want to calculate this. Now we know the value of R1 also. So I can use this Pythagoras theorem here. Okay, I can use this Pythagoras theorem. So I can say simply this length is L by 2. So L by 2 whole square plus R1 square is equal to RCM. That is what I am going to do here. As you can see, L by 2 whole square plus R1 square. When I substitute the value of R1 here, and on simplification I am going to get this answer, and here I am getting RCM is equal to L by 2 tan theta root of 4 plus tan square theta. This is going to be the value of RCM at that particular instant. Now here, in order to calculate this friction, so I can show you here that there is going to be FR1 acting on this wheel and FR2 acting on this wheel. Okay, so resultant sum of FR1 plus FR2, that is going to be our net friction force. And as you can see, the normal reaction is acting in upward direction, mg is acting in downward direction into the plane. So there is only friction force which is going to rotate this center of mass of the cycle into the circle. So definitely direction of this resultant friction force on both the wheels is going to be toward the center of it. All right, and directly I can say it is going to be equal to mv square by RCM, mv naught square by RCM, because it's following the circular path. So here I can write the net friction force is mvcm square divided by RCM. When I substitute the value of RCM, because VCM is V naught, so RCM value I am going to get as from the previous one, this value I am going to substitute here. On simplifying, I am going to get FR is equal to 2mv naught square tan theta divided by L times root of 4 plus tan square theta. This is going to be the answer for net friction force, and it is towards the direction, towards the center of the circle, and it is the resultant of vector FR1 plus vector FR2. And the next part is the coefficient of friction. So I can say this total friction force must be less than or equal to mu into n. This n is combined n. All right, this n is combined n. So when I substitute the value, n is mg here, friction value we have calculated from here. So I should get, for no slipping, this mu must be greater than 2v naught square tan theta divided by GL times root of 4 plus tan square theta. This is going to be the answer for this question. And it was a very simple one, but slightly different application of this concept. So I hope you have enjoyed this video and you have learned something new, how to approach such type of question. So if you have enjoyed this video, please give a like and share this channel with your friends. If you are a student, and if you are a teacher, please share it with other teachers. And if you haven't subscribed my channel, please subscribe it. I'll be bringing more such amazing problems and concept applications in future. Thank you very much.